Here's AP Physics video for Experiment 7. I'm going to give you your hypothesis for this lab. The vector sum of the forces of an object at rest is 0. Here's the setup. I've got a mass on a hook, and there are 2 tension forces holding it up. I'm going to measure those tension forces using 2 spring scales, which you can see the right-hand side of this screen and on the upper left. Here's the left-hand spring scale. Here's the right-hand spring scale, and you can take your measurements. It's a little easier to see if I turn it right side up. I'll give you your angle measurement at 138.5 degrees. And now your task is to do some math, use trigonometry, determine the horizontal and vertical components of FT2, and see if the forces balance out. And continue watching for an explanation.
Okay, so here we've got 3 forces on this knot, and I'm considering the knot as the center. Okay, the knot is the object that I'm considering to be at rest. It's got 3 forces on it. It's got a tension force of 8.1 newtons at 138.5 degrees. It's got a tension force of 6.1 newtons at 0 degrees, right? And it's got a tension force of 5.4 newtons at 270 degrees. Are you with me so far? Then we can use what we've learned about components, our sine theta for y and our cosine theta for x, to find the components of the 8.1 Newton vector. Good. And what you should find is that the horizontal components cancel. So for the horizontal, you get approximately 6.1, or actually negative 6.1, which balances out the positive 6.1. So these two, this dotted line and this vector right here, are the same line, are the same length. They're congruent. And then the vertical component, the positive 5.4, should be balanced out by FG. Now, once you've converted everything to cardinal directions, that's perfectly left and right, perfectly up and down, you can use negatives to indicate direction. So we can say this is negative 5.4 newtons, and FT2y, that's the vertical component of FT2, is approximately the same. So, did we achieve what we thought of the hypothesis? Did we find that the horizontal components of the forces cancel and the vertical components of the forces cancel?
Yes.
Yes. I would like to take a moment then to look at what it means to create a vector sum. To create a vector sum means to add the vectors together. So for if I took FT2, I'm sorry, FT1, that's this vector right here. Can you imagine what it would look like if I take FG and add to it? I'd start here, right? Here's FG. Now this represents FT1 plus FG. Now what happens if I add FT2 to FG?
It'll go this way, the same direction as FT1.
It will.
It'll make a square.
It will make. Well, if I add FT2,
Oh,
I take,
FT2. Yeah, it'll make a triangle.
it'll make a triangle. It'll
Sorry,
take it.
I was thinking the horizontal and vertical components as well.
I see what you're getting at. But this, if I end up where I started, I say that the vector sum is 0. Because my start and my end are the same. So there's no net force, no unbalanced force.